Alright, so now we are looking at finding the area under a curve again, but this time notice there are two functions involved. Notice how they meet in the middle here at the point 2 comma 4. And so if we are looking to find the area under this curve, it can't be done using just a single definite integral. Instead, to find our area, we're going to have to break this up into two separate definite integrals. Now we know this area is going to be positive since it's all above the x-axis. So the first one here, the x values are going to go from 0 to 2, and we're really just sectioning this off here. We're first just going to look at this area underneath x squared, and then we're going to add it to the other area right next to it. So the first area is bounded by 0 to 2 underneath x squared down to the x-axis. So we have that definite integral plus, so we're going from 0 to 2, and then we're going to resume our travels at 2 and go all the way to 6. Remember, your bounds are the x values here. And then in this case we're looking at 6 minus x for our function. Alright, so let's assume that we're not allowed to use a calculator here, and we need to work this out by hand. So for our first piece here, we would have to integrate this x squared. We know that's going to be x cubed over 3. I'm going to write my bracket and then carry down my bounds from 0 to 2. Plus, now let's attack this one, this 6 minus x. Well, when I integrate 6, I'm going to get 6x. And when I integrate x, I'm going to get minus x squared over 2. Again, I am dropping my integral symbol. I'm dropping the dx symbol. Do not bring that along for the ride. Okay, if you do, you're going to lose a point. Alright, so we have that square bracket with our bounds. At this point, we're going to draw ourselves a few parentheses. So for this portion of it, I'll do that over here. We're going to have 2 cubed over 3, so that's going to be 8 over 3 minus 0. Right, we're throwing the 0 in there next. Plus, same thing. Now we're going to drop a 6 into this entire part. That's going to give me 36 minus, well, we're going to have 36 over 2, which is 18. Okay, so I just dropped in the 6. Now I'm going to drop in the 2. That's going to give me 12 minus 2. And now it's just a matter of cleaning this all up. So when we do that, when we get a common denominator, remember 8 is the same as 24 over 3. We're going to end up with 32 over 3 for our exact area. Now, assuming you were allowed to use a calculator, if you were to check this, you would have to enter two separate integrals in fn_int, all right, one at a time, and then add them together, and then you would see that this is approximately 10.6 repeating, or call it 10.667. Okay, would be the approximate answer. So you would have to enter those separately since you have two separate definite integrals. Alright, last example here. So we are looking to evaluate this definite integral. We have the function 3 minus x, which is graphed for us, and although it won't be graphed for you, you'll have to produce this on your own without a calculator if you wanted to see the visual. But we're looking to do this from 0 to 4, and we can see that there's a portion of this that is underneath the x-axis. So we're looking to evaluate this definite integral. Well, you have to understand that definite integrals give us what we call net area. That means it's going to factor in any positive area as well as any negative area. And remember, negative area is just area underneath the x-axis. So it's going to put those two together and give you what we call a net area. Now don't confuse that with a total area, which we'll talk about in a moment. So if we were to just first do this geometrically, it's pretty easy to do. This triangle here we know is 3 by 3, has a base of 3, a height of 3. That's going to give us an area of 4.5, right? 9 divided by 2. And this area below here, it's another triangle, and this triangle has dimensions 1 by 1 because this point here, 4, if we plug it into 3 minus x, we're going to get negative 1. So we can see that this area is 0.5. Alright, the area itself is a positive, but because it's below, it's a negative. So if we were to geometrically evaluate this, we would have 4.5 plus that negative 0.5, which is going to give us a net area of 4. Okay? So when we combine those two, our net area is 4. Well, what happens if we evaluate this definite integral using the fundamental theorem of calculus? So if we do that, we would have 3x minus x squared over 2, square bracket from 0 to 4. Let's plug in our bounds now. So we would have 12 minus 4 squared is 16. 16 divided by 2 is 8. And then if I throw a 0 into it, I'm going to get 0 for the whole thing. Notice how we get 4, which we said is the net area. Now, suppose instead we were asked to find the total area. Well, the total area is going to take any area below the x-axis and turn it into positive. So this would be 4.5 plus a half, so our total area would be 5. Okay. So what we could do if we were to write this using a couple definite integrals, the area from 0 to 3 under 3 minus x, okay, that would give us that 4.5, right, the area of that triangle above. And then if we wanted to take this area that's down below and flip it around and reflect it over the x-axis, what we would essentially do is subtract, all right, because if you negate a function, you're really going to reflect it over the x-axis. So if we were to subtract the area from 3 to 4, okay, then what you're really looking at here is your 4.5 minus a negative 1/2, and then that of course leads to the answer of 5. So if you were allowed to use a calculator, we know that this total area would be the same as if we were to do this all in one shot, so without breaking it up like we just did here, all right, as two separate mini problems, we could do the whole thing by simply putting in an absolute value around 3 minus x, okay, and that would give you 5 much quicker. But that's of course assuming you're allowed to use a calculator. If you're not, then you have to use this idea of reflecting your region below the x-axis above the x-axis by throwing in a negative here. Okay, if we negate a function, in this case we're negating a definite integral, that is going to turn it into positive area. Okay? Okay, so one more thing here. If a question says find the area, so if it's some sort of a word problem and it says find the area, if you're wondering, well, is it net area or total area? Well, find the area, what's implied there every time is total area. Okay? It's when you see these definite integrals, it's not saying find the area, it's just saying evaluate this definite integral. That's when it's going to be a net area. That's when you're going to factor in any area that's below the x-axis and treat it as negative. Okay? So if something says find the area, we're really always looking to find total area, which means any negative area, any area below, must be treated as positive. Okay? So if we look at this previous question and it said find the total area of that region, it would of course be 5, whereas the definite integral is 4. Okay, bye-bye.